Thank you all for joining. My name is Varun. I'm part of the developer experience team here at Chromatic. Today, we're going to be talking about something really interesting, SteadySnap, which is uh, our rendering diffing algorithm, and talking a little bit about how like the different ways your visual tests can have flake and how SteadySnap helps address some of that stuff. And to chat about this with me, I have Scott, who's part of our apps engineering team. So, Scott, I'll hand it off to you just to introduce yourself.
Sure. So my name is Scott Johnson. I'm part of what we call the capture team, and the capture team is kind of like our backend team. We have a whole set of distributed services that we do in Chromatic that most of the time you won't actually see. You'll see kind of the front end, which are web app and front end engineering team. I say front end, but they do a lot more than front end. Our apps team does a whole bunch of different things. When you push a build to Chromatic, it's probably unlikely that you realize how much complexity there is to what we're doing. So we have a whole bunch of different services, and some of the services that I'm going to be talking about today are kind of like the back end system. My experience is I've had kind of like a strange career path because my experience has been in computer graphics and web rendering. So what that means is I worked for a while with Mozilla doing layout in the Firefox browser, and that browser expertise um, has been really helpful for some of the rendering work that we're doing.
Yeah, absolutely. We run tests across multiple browsers. There's like a lot of niche things that happen. There's flake in one browser and not the other, and it's not obvious why that is. So, yeah, excited to get into this. Um, I guess like probably the best place to get started is, could you just like briefly explain how does Chromatic run tests? Like so when you run npx Chromatic, what exactly is happening behind the scenes?
Sure, yeah, there's a lot happening behind the scenes. So when a customer runs npx Chromatic, what we do is we package up that storybook. Typically, it's from Storybook. I mean, sometimes there are other ways to get into Chromatic. So, we have end-to-end tests which involve Cypress and Playwright, but generally, the standard way of getting into Chromatic is having a storybook locally. And when we say we package that storybook, what happens is we'll build it locally on your machine, and so it runs the build storybook npx command or npm command. And then we take that and and we zip it up and we'll send it to Chromatic's systems. And the purpose for that is that we don't have any access to your source code. We only have the packaged system design. I mean, I would refer to it as a design system, but it's not always the design system. It might be a fully functional app within Storybook. And and so then we have a system of services that then kind of run in order, and they're kind of controlled by what we call our dispatch system. And so the first thing that happens is extract. And extract, the purpose of it is that it extracts the stories, literally undoing the zip file. But it also does a whole bunch of other things, and that is that it prepares the storybook, and it labels the stories and how many tests are in each story for the capture system. And it then creates this what we call a build within Chromatic, and that's sort of like this event that says, "Hey, I've got this group of stories. We want to run a a set of tests against existing baselines, assuming you have run tests before. If you haven't, then what it'll do is we'll just kind of go on with the process. But this is a really crucial step because we need to establish what we call a baseline, and that is what images are we going to compare against when we get to the end of the process. And that system takes into account, it's really actually really complicated, and it takes into account the get hash of your current commit. It takes into account what branch you're on. It takes into account like whether or not you've accepted builds or denied them in the past. And from there, we go to our capture cloud, which is just a fancy way of saying like a series of services that um, load the storybook and launch browser instances so that we can see each one of those tests. And then we run the interaction tests that you have, if you have them in your storybook, as well as actually just loading the rendering of that particular story within the specified browser. So you can run on we have a whole bunch of different browsers you can run on, Chrome, Firefox, um, we have Edge, Safari, and it'll load. And we're actually working on some mobile stuff too, which I don't know if I'm supposed to say that, but we are. We're
Yeah.
working on React Native for Android. And then so it renders it in the browser, takes the screenshot, and then we compare it against the baseline screenshot. And so my primary work has been in this last part, which is we call diff, because it creates a comparison between the two images, and then sends that back up to the dispatch server to say, hey, I found a diff, I didn't find a diff, and that's kind of the part that we're going to be talking about, I think, today.
Yeah, absolutely. So I'd say like for more design system type components, generally visual tests are fairly straightforward. There isn't a lot of like re-rendering happening. But, you wait for the browser to load and you capture a snapshot, and that's usually fine. But we tend to have fairly complex UI that a lot of our customers use for visual testing. Uh, there's a lot of design systems, but there's a lot of like application components, more sort of composition of components, even entire pages. And that's where you get into those inconsistencies. So um, at a high level, just like what does Chromatic do to avoid that kind of inconsistency?
Right. And that's so just to kind of back up and kind of talk about like what the inconsistency is, because it is possible that Chromatic's a really stable platform. And so it is possible that there are folks on the call that probably have never run into an inconsistency. And so what we mean by inconsistency is a situation where for one reason or another, a snapshot is taken and it does not align with the baseline. So there are one or more pixels in the resulting image that are different from the baseline image, but it doesn't happen repeatedly. What that means is, for example, you might get a strange change in the anti-aliasing of fonts. And then so you run it, it says, oh, hey, there's a diff, and it brings it up to you, and you're looking at it and using our tools like our focus diff and some of the things that we present, you see, oh, well, I don't want that, right? So what's the first thing that you would do next is probably rerun the build. And so you rerun the build, and then it says, oh, everything's green. It matched the baseline. So this can be super frustrating. It's inconsistently rendering. And we sometimes refer to this colloquially as a flake, meaning that something in our rendering did not produce the correct result, or it doesn't always produce the correct result. And there are a number of different tools that we provide to mitigate this. One of them, and prior to SteadySnap, which I'll talk about in just a second, we had what we called the snapshot debugger, and or the inconsistent snapshot debugger. And this is a great tool where you can rerun the build, and you can actually look through, how did the rendering happen? At each stage, like which frames were wrong, and how did it paint? And this is a great tool for debugging something where you have like, let's say you have a button that maybe is like shifting kind of back and forth, and for some reason you don't understand why that's happening, and it probably has something to do with margins or padding being incorrectly applied at different stages of the rendering during the browser's layout. And that is great to debug with the snapshot debugger, but the problem with the snapshot debugger is that we don't record every single snapshot that we take. There's a lot of data that comes in. If you're familiar kind of with code compilation, you don't always, you don't compile your code with debugging symbols because it just takes up so much more space, and it's unnecessary to the end user. And for the same reason, we don't run all the time with the snapshot debugger running. So what you have to do is you have to rerun the build, and then the snapshot debugger will record that. But what happens if the flake doesn't happen on that build? Now we're in this weird, situation where it's so hard to kind of nail down that situation. And so one of the things that we as a capture team kind of had been debating for a while was, um, what can we do to just make it just work, right? Like that's one of our principles. We want it to just work. Um, and the the idea is we're going to have a multi-phase um, of differencing. So I talked a little bit about the dispatch service, which is kind of like the controller for um, coordinating the different services that we have. And so what we did was we came up with this idea that, well, let's do a preliminary, like really quick diff, for example. So, and in this case, like not even send it necessarily to our diff service, which does a pixel by pixel comparison. But let's just say, if we were to do a SHA-256 hash on the two files, and they're exactly the same, we know that the binary data in those files is the same.
Hmm.
And that's really quick, and we can just exit early. Um, and then from there we could also send it. Okay, well, what if the SHA-256 hash doesn't match? Then we send it to our diff service, and the diff service will then decide. Not only does it decide whether or not that's an actual difference, because there is a possibility that maybe it's in the metadata of the file, for example, and the actual
Right.
content of the image data didn't change. That does happen sometimes, believe it or not, where the hashes don't change. It sounds like an outlier case, but it's not. Um, where the hashes do change, but the actual image data is the same.
Right.
And so in that case, diff runs and it says, hey, there's no pixels that have changed. Just go ahead and pass it up as a green test. And then there's a situation where, okay, the diff algorithm or our diff service decided that there is a change. And what we get from diff is not just, hey, there's a bunch of pixels that changed, this is wrong. We also get each individual pixel that did change. And you can run diff with multiple different thresholds, and because it's kind of a color differencing
Hmm.
operation. Um, and I can get into that too if people have questions, but um, we'll just suffice it to say that diff's going to say, each individual pixel is either different or not from the baseline.
Right.
And so then dispatch it comes up to dispatch, and dispatch says, well, let me just make sure, right? So so in that case, um, it'll run it again,
Hmm.
and it'll say, and we do some heuristics too. So I'm simplifying the process just for our listeners, but there are times when we decide not to engage in this process and not to run another difference, and it's based on heuristics on um, how many times the build has been rerun because of this test. It has to do with whether or not. So we're trying to detect at a high level, like whether it's likely or not that this was a flake or whether it's a legitimate difference.
Right.
And that's a key. I mean, that's a really key and important problem. And we're also exploring, just as a kind of an aside, we're also exploring possibilities of using AI for that. Um, but I'll just continue kind of on with the process. And so what then happens is our system says, hey, take another diff, take another look at this, and it will re-render the snapshot, and it sends it to diff. And so now you have snapshots, your baseline snapshot and snapshot one and snapshot two. And so if snapshot, the first snapshot, um, matches the second snapshot, but they're both different from the baseline, then we have a legitimate diff, and we're going to pass that back. If, however, the second snapshot does not match the first snapshot, but it does match the baseline, then it's a flake, and we'll basically determine that we're going to mark that so that we know in our metrics that that was a flake.
Right.
Um, and then pass it up as an accepted build, a green build, back up to up through into the app.
Right.
There is a possibility. So SteadySnap has a I mean, there is a possibility to disable SteadySnap in our backend system. And so that does not happen if the app has SteadySnap disabled. And a lot of these, like I talk about the heuristics, and it's really important. It was really important to us that Chromatic is a reliable platform, and that we don't ever pass something up when it's like, we don't want to mark it as accepted when there actually was a legitimate change. Like
Yeah.
that is a hard stop for us.
Yeah.
And because thousands of customers rely on Chromatic as their, that's the gatekeeper. Like that's the, hey, your UI changed and we're not going to let it get to production. So that was really important. So there's always an out for customers, because there is a little bit, whenever you work with heuristics, there is a little bit of risk. So if a customer is just completely risk intolerant and they would rather have the inconvenience of having to apply, accept that flake manually or rerun their builds, that's completely up to them.
Right.
And it's difficult to get a very perfect system.
Right. Yeah, no, that totally makes sense. So yeah, I think you touched on this, but there's kind of like two broad categories of flake. There's things that are there, you're seeing differences that are reproducible, and each time you rerun, you're getting the same difference, and that might be because an interaction test isn't working as you expect it to, or a static resource that you're loading is failing, something like that, right? And that's where the trace viewer is super useful for debugging that stuff, because you can
Definitely. Yep.
effectively, if you folks haven't tried out trace viewer, it is giving you the playwright trace viewer for the build, so you can go and see like essentially it's like the browser dev console, but for the entire run, and you can see what's happening if a resource isn't loading. So that's really helpful. But the second big category of flake is the inconsistent one, where sometimes it's flaking out, you rerun and it disappears, or you rerun and it comes back again, like the third time, fourth time. And those ones are really hard to debug because you can't consistently reproduce them, so you don't really know what's causing it. And that's where SteadySnap comes in and does a lot of the stabilization. By the way, before I move on, I should mention, please feel free to ask questions as we go along. You can either use the Q&A tool, which is very helpful for us to track stuff, or drop it into the chat, and I'll keep an eye on it. But yeah. So let's talk about those inconsistent issues, or the intermittent issues where, it might be things like dynamic content on the page where, there might be CSS animations or a video playing. So what's happening there? Like, how do we ensure that that isn't, we're not pausing a video at a random frame every single time to capture the snapshot?
That's a great question. And so when we have dynamic content, we have to make it, we want to make the system deterministic, or as deterministic as possible, right? So every time you run a particular page, you get the same result. And some of the inconsistency that comes about is because things aren't necessarily, there's a timing issue, right? So if you can think of, like, if you were to just take a manual screenshot of your browser while you're playing a YouTube video, well, you'll probably just get a black screen because YouTube has DRM in it. But let's assume you didn't. And you take this screenshot, you're probably not going to get the exact, down to the millisecond, the exact same frame every single time. And so what we do is we mitigate some of these problems by, some of them are easy. Like, for example, CSS animations are pretty easy to disable, and we can either pause on the first frame of the animation, or we can let the animation play out till the end frame. And that's actually up to the customer. Like, they, if you want to set it to, so that because sometimes what you really want is, if you think of like a tabbed menu, for example, right? And you click the tab, and it sort of brings down like this menu with an animation. Really what you care about is not the animation or the first frame. You care about what is the end result that the customer is going to interact with,
Yeah,
your
totally.
customer is going to
Yeah.
interact with.
You want the
And
menu to be
so,
open.
exactly, yeah, you want the end state. So that's perfectly fine. Most of the time, videos are paused in one of two ways. We will, because videos are a little different. You typically don't want it at the end frame. I mean, sometimes you do if you want to make sure that you have like a banner ad as your last video frame, but um, typically that it's kind of irrelevant because you would test that before you sent the video to production. So instead, what we typically do is we'll pause the video on the first frame. Um, and again, it's sort of irrelevant whether you pause on the first frame, the last frame, whatever, just as long as you're not pausing somewhere in the middle and it's not the same frame every time. And video, the way video runs on the web, is it's typically decoded by the hardware. And so there can be a little bit of a timing issue, um, even if you have it to autoplay on start of the page. So you have it autoplay on start. So what we do there is we do one of two things. We'll either, well, we always have to turn autoplay off, which sounds like it's a really easy problem, but it's actually not because some video playing mechanisms, like the
Yep.
libraries that you use for video playing are kind of difficult. And we can't, um, we can't decode the video directly. So that's an important consideration, right? So the browser handles the like DRM and the decoding of the video. Again, typically in hardware, so it's a pass through to your video card. Um, and so we don't have the actual video data where we could decode and just get each individual frame of the video. And especially if it's like H.264 where it's like progressively encoded,
Right.
um, you wouldn't be able to do that anyway. You have to have some previous frames. You have to start at the last keyframe. And so we can't do that. What we can do though is we can, if you have a placeholder banner, which is very common in some video playback frameworks, we'll display the placeholder banner, and it's just an image effectively that holds the place of the video while it's loading from the network.
Right.
The other thing we do is we'll load the video completely and reset the clock to 0 and then pause it. And then we'll do that. And as we take our snapshot, so we don't just take one snapshot. I kind of glossed over this at the beginning, but when we capture, what we'll often do is we'll take repeated snapshots. And so we wait for all network loading to be done. And then we'll start taking snapshots, and we start taking snapshots, and we'll stop once we get to a set of consistent snapshots where it's like, oh, this hasn't changed. And then
Right.
that will be our canonical snapshot for that run of capture. So when
Right.
I talk about SteadySnap taking snapshot 1 and snapshot 2, that whole process happens um, for each of those snapshots. And so we're already trying to like create some consistency so that we're not and you can see this with the trace viewer. You can see like images will start loading, fonts will start loading, things will start being laid out, and you'll be able to see each individual frame as it's taken. Um, and so we're taking snapshots at the end of that process, and we're saying, oh, okay, are you done yet? Nope. Oh, are you done yet now? Oh,
Right.
okay, yep, now it's done.
Right. Yeah, because there's like we can monitor the browser and make sure that resources are loaded or the DOM content load event has fired, but it's not really telling you that the UI is ready to be captured at
Right.
that point, right? Because like a lot of JavaScript can be executed, like CSS transitions have to be paused, but there's like all kinds of stuff that could be still happening, and that's where that comes in, where we're capturing multiple snapshots, and until we feel like, hey, the two back-to-back snapshots matched, and now we feel like things are stable, and now we
Right.
can we can move forward. But yeah, that totally makes sense.
Interestingly, we also experimented with not just two. I mean, we've kind of landed on two because if you have two back-to-back snapshots, it's probably not going to change after that. But we,
Right.
we originally thought about, well, what if we went further and went like three or even four? And it just turned out that there was just such a
Overkill.
diminishing benefit.
Yeah, that makes sense. So I have a question here from Jason. Is SteadySnap enabled by default? Yeah, absolutely, Jason. We rolled it out silently sometime in March, and found that like it worked quite well. Reduced visual inconsistencies by 34%. You can choose to turn it off, like Scott mentioned, but it's not an option that's available from the UI. You have to reach out through support to get it turned off. But yeah, by default, we do have it enabled on all accounts. And there isn't like
Yeah,
a
it's not something I'd recommend turning off.
yeah,
Um,
absolutely. Yeah,
you're like I did mention the risk level, but the risk level is so small that unless you're really um, I guess it's possible that you might be rendering something that you absolutely need every single anti-alias pixel to be
right.
correct. Um, in that special case, but you're going to get more benefit than you're going to get negative from it.
Yeah,
It's
totally.
not something that we wouldn't have rolled it out if there was a huge risk.
Yeah, yeah, absolutely. And Sean, Sion, is that how you pronounce your name? Sorry. Um, Touched on sort of the cost aspect of those multiple snapshots. So I should clarify, there is in the capture process, there are multiple snapshots that we're capturing until things stabilize. So that Chromatic does not charge you for. All of that is just the process of capturing one snapshot that is then compared against the baseline. But yeah, you get charged for the one snapshot. So effectively, it depends on sort of the number of stories we're testing and so on. But in that process, there are multiple snapshots that are being captured. And I feel like we should have like a different term for it, but effectively, it's like that's where like multiple screenshots of the browser are being captured. But then, yeah, internal snapshots is a good way to describe it. But effectively, the snapshot that we capture is the final one where we feel like this is stable and has all the metadata attached to it, and we can then move on to the diffing side of things.
The way I think about it is like the end snapshot that you get that you can see in your build is what you pay for, right? So
Yeah,
everything up to that is part of our process to generate that last one.
yeah, absolutely. I mean, the thing is like most folks don't use visual testing because they've been burnt by Flake in the past. So from our perspective, we feel that things like SteadySnap or taking those multiple internal snapshots, it just leads to more consistent results for our users. So we want to invest in that, and that's why we offer SteadySnap for free. Because if you're getting consistent test results, then it means our tool is helpful. And if you're just having to deal with Flake all the time, it just means you stop trusting visual testing, right? So that's not a good result for anyone involved. So yeah, that's why there's no additional charge for
And I
that.
mean, testing in general is less valuable if you have fragile tests, right? So we want to reduce the fragility of these of this suite.
Absolutely. So I think one more aspect I want to touch on is um, even with like monitoring the browser and everything, you do end up with components that will re trigger a reprint or a redraw. And usually this is like dynamic UI or like
Mhm.
graphing libraries are really bad for this, like where they'll everything settles and then suddenly boom, like there's like an axis that shifts or like the scale changes or something. What is that where again we're kind of just doing this burst capture or capturing these multiple internal snapshots, or is there something else happening behind the scenes there too?
Um, when we talk about really dynamic stuff, so like for example, a WebGL context, um, we don't really support WebGL context right now. I mean, you can get it to work, but the problem is that, and that's kind of a special case, right? When you've got a canvas, it's being redrawn, ideally at 60 frames per second, or higher if you can support that. Um, but we can't capture at that rate. So like we're never going to be able to. You're never going to be able to say, I want to capture frame 265 this
Right.
WebGL animation, right? So um, that becomes a difficult issue, especially considering um, the hardware differences on the capture cloud. They're very different from what you're running on your local hardware. So frame 265 for you might be very different from frame 265 up there. Now, when you're talking about dynamic UI, about things like you know, simpler dynamic UI, like your graph, like when you're talking about like graphs, for example,
Hmm.
that maybe reframe, or an SVG maybe would be a better example, because sometimes you can render, because an SVG document is actually just a DOM in itself, so it's kind of like an embedded DOM. So you can have a pretty complicated animations happening, and it's all still just in what we would consider to be the DOM, like the document. And when we do when we do that kind of rendering, what will that's where our consecutive snapshots will really help to um, to not give you inconsistent snapshots. We also have a number of different modes for controlling the viewport, right? So if you want to specify it to be like a little bit narrower for a width for mobile, for example, and then see what your graph renders when you have that dynamic content. That helps a lot, because anytime we have the constraints ahead of time of what you want to be seen, that way we can stabilize for that specific set of constraints. Um, Hopefully, I didn't misinterpret the question though, Varun. Was that?
No, no, no,
Oh,
no. Yeah, you definitely got that. So I think that kind of like touches on like the different things that SteadySnap covers, right? So if I were to recap, there's the render stabilization, so just like understanding where the browser is at in its current timeline, and if it's even like a good time to start capturing. Then it's freezing dynamic content like videos and animations and stuff.
yep.
And then lastly, there's the burst capture where we're capturing multiple snapshots and then waiting for things to stabilize and then settling on the last one. Um, Outside of that, are there any recommendations that you have for folks for just how would they approach writing tests for the tests themselves to be more stable? Like obviously we're trying our best with SteadySnap to take away those intermittent issues that can happen and reduce flakiness, but is there something that folks can keep in mind when it comes to writing tests that will ensure that there's less flakiness?
Yeah, I mean, these are pretty standard kind of like testing guidelines, right? Make sure that you have an end state that you want. One of the hardest things to test is when you have an infinite animation. And so for example, a loading spinner, believe it or not, is actually kind of a strange test. But as I said, we handle it just by having the first frame. Um, but if you want a a loading spinner where you're trying to capture the last frame of the animation, like that doesn't make a ton of sense, right? So like
Hmm.
thinking about, you know, what is it that I actually want to be testing? Um, Obviously, the other thing is there's a cost value proposition here, right? Whenever I'm writing tests, whether it be integration tests or unit tests or visual tests, um, I what is I always kind of take a step back and think like, what am I trying to achieve? Um, and oftentimes I'll find that, if I'm just trying to achieve 100% test coverage, like that's great. I mean, you get a really great feeling for getting the green 100% test coverage in your unit test, right? But is that effort worth it?
Right.
And in visual tests, this is even more important, because you really have to think about what am I'm trying to prevent regressions, or at least that's how I view things in when I do it, because I use Chromatic for I run a small martial arts school, and we have a website, and we have a storybook design system that we use and we push it up to Chromatic every time I make changes. Um, and oftentimes what I want is, I don't care about, if we're using, for example, images from a CDN and they get re-encoded and recompressed every time, like that's a
Right.
lot of noise. And I don't really have any inclination to go through and figure out, like, okay, how can I get that image to be the exact same thing every time? Like, that's not something I care about.
Right.
What I care about is, does the layout of the page look right? Do the menus, like I've had regressions in the past where you mouse over a menu and the drop down comes out, and it's, because I'm using an unordered list, it's all in a line because my
Hmm.
style somehow got messed up. That's the
Right.
kind of stuff I want. I don't want to make to production. I don't want especially in the martial arts website, because I'll probably push a change on a Sunday morning and then, oh, looks good. And then I won't change it for 3 months.
Right.
So if I get a regression in there, it's stuck there until
Yep.
I notice it. So
Yeah, the images is a good point because like like we generally recommend folks to have those images that they're using in stories be loaded locally within Storybook through the dev server. But yeah, sometimes you definitely rely on a CDN where we see this that the images have like slight encoding issues and you get a bit of noise and it flags a diff. So in that situation, like you said, maybe the better trade-off is just to mark that image as chromatic ignore. So like use the data attribute or
right.
the class to ignore it. And what that's going to do is not do a pixel by pixel comparison on the image. But if your CDN goes down, for example, and the image doesn't load, that breaks the layout. And now the dimensions of the container changes. So that will be flagged as a diff. But if the image is loading and there's like slight encoding changes, it's not going to get you to re-review that every single time.
Definitely, especially if you're using images that are like PNGs are one thing, but if you're using an image that's like compressed, internal compression using lossy compression like JPEG, right? So JPEG, the way JPEG works is the compression encoding works in a way that you will get it compresses the high frequency areas. And so when what that means is that if you have a picture of like of a landscape, right, a really beautiful landscape, chances are your grass is going to be a little different every time because that's a really high frequency area. But the
Right.
sky is going to be a consistent blue, and that you won't see changes in that. Um, and oftentimes, developers might not know this, but oftentimes the way CDNs work is they'll store image in a high resolution or raw format. And it's a high DPI format on, sometimes even uncompressed on their systems. And then you request what size do you want. They do a little bit of juggling around to make that size. They do clipping and whatnot to create, you want a square image
Right.
with a center at this point. And then they compress over the wire, meaning that it's sent, it's compressed, but only compressed during transfer. And so what happens is that encoding and decoding on either end can sometimes result in, if especially if it's lossy compression, can result in
Right.
in a weird artifact on the other side. And so yeah, as Varun was saying, like, you know, be conscious of that. And we offer ways to mitigate that. And so rather than rewriting your whole architecture to not use the CDN, maybe it's better to just ignore that region. I mean, is the image going to change? Like that's a CDN problem, right? Like, I mean,
Mhm.
that's not your problem. Like it's not going to change
Right.
your layout, or hopefully not. Like that's what we want to catch is if it does.
Right. No, absolutely. I another question here from Pavel. It's a question about how the test SHA is calculated, i.e., if there's a story that hasn't been modified, but a component has scope styles with CSS variables and other CSS files with those variables modified, I found those stories to be marked as turbosnapped and not checked, i.e., the story or component didn't change. Is there any way to avoid this other than disabling only change for a build? If I were to summarize this question, the idea, what's happening here is the CSS perhaps scope styles associated with the component has been modified, but Chromatic still thinks that it's nothing has changed because of TurboSnap. And for folks who are not familiar, TurboSnap is a feature in Chromatic where we use the build information. So when you run a Webpack or a Vite build, we're using the dependency graph to analyze and see which files changed. And if the file has changes associated with that, then capture a new snapshot. Otherwise, copy over an existing one. So in this case, the idea is that CSS files changed, but Chromatic is still treating it as things haven't changed. And uh, I can answer this one. I think in this case, there is a TurboSnap configuration, which is external files. So if you mark CSS files as an external file, and anytime those files changed, it is going to trigger a full rebuild within Chromatic. So it's going to capture new snapshots. So that's a good example of that because um, depending on your build setup, sometimes Webpack and Vite might know that a CSS file was changed and it's being imported into a module, but in your setup, those files might be loaded in a different way, and it doesn't have that information. So if it in that case, you would rely on that external thing. Anything else you would add there, Scott?
Um, yeah, TurboSnap is really useful. We didn't really talk. We It's kind of separate from the rendering stabilization issue. Um, I think maybe the best thing that I can say is kind of stay tuned for that, because I think we're still tweaking TurboSnap a little bit, and we're going to. I think the idea is we're going to be introducing um, different ways of generating that. We're doing experiments right now to generate that dependency graph in a maybe a little bit better way. Um, the the practical advice that Varun just gave is great, um, but there is this question of if I have 30 stories in my story file and I change the story and I change the CSS file for one of the components that that story depends on, should all of the stories be run? I mean, that's a great question, and I mean, I think it gets into a little bit more. I love thinking about theory, but it gets into a little bit more of the theory of the syntax and the dependencies and how do we create that dependency graph. And like Varun said, we're really relying on the external tool, whether it's Webpack or vBuild or I think we support RSPack now too.
Yes. Yeah.
Um, and and those can all be slightly different, like how they create that dependency graph. And so I mean I think that's we're working with that, I guess is a better way to put it. But for now, yes, just use the external files.
I will link to our TurboSnap guide, which has some a lot of explanation around this. So hopefully that should help you, Pavel, on how to set up some of those flags. But I think that's everything I wanted to cover on my end. I'll give folks a chance if you have any other last questions before we wrap things up.
Just talking about TurboSnap is kind of a I for the folks that don't know, when we have you ever talked, Varun, about an empathy rotation? Like what our so sometimes
Not
it's not just support that actually is helping some customers out. Sometimes it gets escalated to myself and other capture developers or the apps developers, and we call this empathy, meaning that we should have empathy for our customers. And so we're trying to help you. Um, and I would, I think that sometimes it's not well known that we TurboSnap is a complicated beast. I'm deciding what to TurboSnap out and what not to is complicated. And so um, you know, if you're having issues with TurboSnap, I would encourage you to reach out, because I think that we want to help you. And if we don't know that there's problems that you're suffering with, don't just suffer with them silently. Like, we need to know as developers that there's a problem.
Yeah, absolutely. It is a very cool feature because it
Oh,
just
definitely.
uh makes testing more efficient, like just time wise. Like your builds run much faster and with takes up fewer snapshots. But because the way we build front end applications, things are quite complex. There are like asynchronous modules you might be loading, and we package images and CSS and everything through the same build tool chain, and everything impacts the end rendered UI. So it's not trivial, like how things are being rendered and whether we're tracing things correctly or not. So yeah, like we in the last few months, our team has added a lot of nice resources to the docs that explain some of those dependency tracing. And there are the second link I shared here, it goes through a tool that helps you trace dependencies to see, why exactly is this story rerunning when I expect no change, and you can see like what files chromatic things cause that change, and see whether that's a reasonable expectation or not. Or in some cases, you might want a story to rerun it, but it's not because you're missing an external dependency that's not part of the build setup. So yeah, absolutely reach out. Like Scott said, we have the engineering team that helps out answer these questions. So that they these are the folks who build the tool, so that they're kind of in the best place to answer those questions, and hopefully we can work through some of those challenges that you might be having. Cool. I think that's everything. I don't see any more questions from folks. So thank you all for joining. This was great, Scott. Uh, I I work on chromatics. I understand some of this stuff, but even for me, I feel like I learned a lot of new things here today. So thanks a lot. And
You're
uh,
welcome. Thank you for inviting me. I love talking, especially getting this kind of um, FaceTime with our customers directly.
yeah, absolutely. And like even getting into the details which you might not see in the documentation, or when we announce these things. So yeah, thank you for that. All right. See you everyone.